Hi, in this video, we're going to talk about simplifying trig expressions, which is the first objective in section 5.1 of chapter 5. In the first two videos, we got familiar with some trig identities that will help us simplify expressions. Those identities, you can see them on the right side of this whiteboard. We will be using them to simplify trig expressions. We're going to start with the first sample problem. And just to keep in mind, when we say simplify, that does not mean solve. We simplify expressions, we solve equations, and we will talk about the difference. Example 1, sine cube of x plus sine x multiplied by cosine squared of x. And the question is, simplify the expression. This is definitely not an equation. We don't see an equal sign on the right side to the equation that is equal to any quantity or any other expression. So we do not have that right side with the equal sign. Therefore, it's not an equation and we are not solving. We are simply simplifying. The biggest challenge with this objective is that there's no step 1, 2, 3, and 4. There's no one method that you could use to simplify all the expressions. It definitely requires lots of algebraic skills. It requires practice so you can get familiar with some methods that you could use, and it definitely requires the use of trig identities. The ones we covered so far are the quotient, reciprocal, Pythagorean, cofunction, even and odd. So let's start with this. I look at this expression and I see a square in here. And that squared reminds me of some identities we talked about, which are the Pythagorean identities. I see a cosine squared, but I see a plus sine squared. If I look at the given expression, it doesn't have a sine squared. It has a sine cubed. So that's why I want to make sure I rewrite this in a way that it will show a sine squared in it. So think about t cubed. How can I write t cubed in a way to show a t squared in it? T cubed will be a t squared multiplied by t, because when we multiply, we add exponents. Similarly, a sine cubed is a sine squared multiplied by a sine to the power of 1, which is simply sine x. Plus, we will copy everything else down. This is the first step. Second step, we see a common factor. We see something repeating, which is that sine x. We can't simply cross them, we can't add them because this is a multiplication, and one of the most important ideas here is to know that, for example, sine x is a block. I cannot separate this into sine and x. This is not acceptable. We cannot separate them. It's a block by itself. When I have an addition, I cannot just add the sign and the sign since they are attached to another factor. Therefore, I can use something called factoring, and everyone learned the factoring skills not with trig functions but with regular variables. And I can remind you using the example of t or x. Let's use t. So if we have t cubed plus t, the way we factor this, we see a common factor. And we say, for example, what's left? So t cubed divided by t is t squared, and t divided by t is 1. That's the reverse process of distributing, which is the factoring. I look here and the common factor is sine x. I open parentheses and I see what's left from the first term. If I take the sine x and I put it as a common factor, what's left is sine squared of x. And I see what's left from the second term. And I'm color coding this so you can see it. The highlighted part is the common part. That's what I put right here in front of the parentheses, and I'm going to label this as a common factor. In parentheses, what's left from the first term is the sine squared, that's that blue part. And what's left from the second term is that cosine squared, which is the pink part. Now, this, what's in parentheses, should remind me of identity 9. So I'm going to put right here that I will be using identity 9, and I want you to do the same with all practice problems. You should specify which identity you're using. That way, you'll help yourself getting more and more familiar with the identities. So I'm going to copy the sine x down, which is the common factor. And my parentheses, I'm going to substitute sine squared plus cosine squared with 1. And now, multiplying sine x by 1 will just give me sine x. And that could be labeled as the simplest form or the simplified form. So we want all the way from our starting point, which is sine cube x plus sine x multiplied by cosine squared, to the simplest form, which is sine x. So that was the first example. Let's take a look at the second example. The second example is a little bit more complicated, or I would say different. And with every example, I'm trying to remind you of basic algebraic skills, and I'll put them to the side for you to remember the rules we need, the algebraic rules we will need to simplify those expressions. So this is how example 2 looks like. It's secant x plus 1, in parentheses, multiplied by secant x minus 1, all divided by sine squared. If I look at the pattern, I should remember a special case I learned in Algebra 2 and in pre-calc, which is a plus b into a minus b. I have the same two terms, a and b, which are one time added, one time subtracted. Another example, t plus 3 into t minus 3. How would I distribute this? So here we're going to do the opposite of what we did in example 1, where at this step we factored. Right here, we're going to have to distribute using a squared minus b squared, or a minus b into a plus b patterns, special case. And that's why we said there's no way to generalize and say, this is how I'm going to simplify all trig expressions using that one method. And a minus b into a plus b could be distributed as a squared minus b squared. So this will be the first term square minus square the second term, which is t squared minus 9. Of course, you can distribute this in the traditional way, but you should definitely know your special cases. They are super important. If you distribute this in the traditional way, you will get t squared minus a 3t plus a 3t minus a 3 squared. And those middle terms cancel out, and you will be left with the middle t squared minus a 3 squared, which is the a squared minus b squared. So now, how would I do that? First term is the secant x. That's the first term. So that first term, I'm going to square it. That's what my special case does. Minus b squared. So the second term, square it. So I'm going to change the color to highlight the second term, and I'm going to square the second term. And 1 squared is just 1, so I'm not going to use another step to write that 1 squared is 1. We can do it at one step. And then over sine squared. Now I look at my numerator and I say, where do I see in my trig identity sheet a secant squared? So I look at my identity sheet, and a squared is also seen in the Pythagorean identities. So secant squared is equal to 1 plus tan squared. So I'm going to substitute secant squared according to identity 12, 1 plus tan squared of x, not theta in this case, and I'm going to copy that minus 1 over sine squared. The ones cancel out, so I'm left with tan squared divided by sine squared. And tan, remember, when we want to simplify, we always want to write everything in terms of basic trig functions. And the basic trig functions are sine and cosine. Those are the building blocks of all other functions. And you can see that how the tan is built of the sine and cosine. Similarly, the cotan, the cosecant is built of a sine, the secant built off a cosine. So our building blocks are sine and cosine. So what's tan in terms of sine and cosine? According to identity 1, tan is sine over cosine. But right here, it's tan squared. So it's sine squared over cosine squared. And divided by, I'll just copy whatever is left. We're taking our time with this so you can really understand it. Now we are at a step where we are dividing and there are fractions included. When we divide and there's fractions, we do the keep, change, flip. So we are gonna keep, change, flip, and we are going to do sine squared divided by cosine squared and change the division into multiplication and flip the bottom fraction. And that will leave us with sine squared that could be canceled out, and the simplest form in this case will be 1 over cosine squared. So that will be the simplest form of example 2, or the simplified form. So now it's your turn to practice page 410, number 9 through 22.